Welcome to Mr. Morse's virtual classroom. Today we're going to be graphing logarithmic functions. Our main goal and objective is to know by the end that logarithmic and exponential functions are actual inverses of one another. So this was what we had done before. We know that y would be equal to 0 in this problem because there's no shift. And if I were to create a t-chart for 2 to the x value, I would plug in the numbers -1, 0, and 1 and end up with getting 1/2, 1, and then 2. Alright, and if I were to graph it, it would have a horizontal line here for my asymptote, and then I would have -1, 1/2, 0, 1, and 1, 2, and it would end up looking something like this. Okay? Pretty close to what we're doing today, except for now, if I were to graph the inverse, what's going to happen is it's no longer going to be y equals 0, but it's going to be x is equal to 0, which is going to be a vertical line. And my coordinates are now not going to be -1, 0, 1. My -1, 0, 1 are now going to be my y's. And my x values are going to now be 1/2, 1, and then positive 2. So if I graph that, I'm going to get 1/2 -1, which will be right here, 0 or 1, 0, which would be here, and then 2, 1, which will be here. So we're graphing the inverse, but the only thing that's really changing is my x's and y's are flipping. Alright, so inverse of an exponential function and having a vertical asymptote are the major differences in logarithmic functions. The way that we're going to do that is we're going to write the exponential parent function, make a chart for the exponential, find the inverse, graph, and then shift. So let's go ahead and go to our first example. We've got log base 3 of x. All I really care about is this base of 3. Now, if I were to change this into an exponential form, which you don't have to write, I would have 3 to the y power is equal to x. We then flip x and y to get 3 to the x is equal to y. So I'm going to have technically two t-charts. Okay, there's one that is going to be used for logarithms, and there's one that we're going to use for our inverse of those logarithms. So if I do 3x, I'm going to plug in just like normal -1, 0, and 1. And when I plug that in, 3 to the negative first is going to be 1/3, 3 to the 0 power is going to be 1, and 3 to the first power is going to be 3. We just learned that the inverse of that would be just flipping my x's and y's. So 1/3 -1, 1, 0, and 3, 1. Since there are no numbers here or here, we're not going to be doing any shifts for this example, but just keep that in mind when we go into further examples that there's going to be numbers that change our graph. So we know that our asymptote is now not y equals 0, but x equals 0, so I have a vertical line at x equals 0. I have the coordinates -1, 1/3 -1, 1, 0, and 3, 1. I don't have any shifts to do, so I can go ahead and draw in my graph. And since my domain for my last problems was negative infinity to positive infinity, now my range is negative infinity to positive infinity. And that makes sense because my graph is starting from the bottom. It's going all the way up. I know this is an arrow, but it's still continually going up from there. So that's why it's negative infinity to positive infinity. My domain is going to also work with whatever my asymptote is. So 0, so it's starting at 0 and it's going to the right. And it's going to continually go to the right until it goes to positive infinity. So my domain is going to be 0 to infinity. Alright, let's go ahead and do 1/2 x. So all I really care about is the 1/2 to the x value. Really what I want is this number, and I'm going to put it to x. Okay, sorry, I'm trying to get this so it doesn't look terrible. 1/2 to the x value. So we don't care about anything else. If there's any other numbers, we'll worry about those at the end. But let's go ahead and plug in our numbers, -1, 0, 1. If I plug those in, I'm going to get 2, 1, and then 1/2. right? 1/2 to the negative first, 2. So my logarithmic equation, or my t-chart, is going to be 2, -1, 1, 0, and 1/2, 1. All right, so let's go ahead and graph those. Remember that my asymptote is going to stay at 0. So I'm going to go ahead and make my asymptote x equals 0. I'm going to graph 2, -1, 1, 0, and 1/2, 1. I'm going to go ahead and draw on my line. Okay, my range is going to stay the same for all of these. It's going to be -infinity to +infinity, and you would think the domain would change, but it doesn't. It still goes from 0 and it goes to the right to infinity. And remember, we only care about this asymptote, so 0 to infinity would remain my domain for this problem. Okay, let's do number 7. All I care about is this base number, so 2 to the x power. Okay, if I were to plug in -1, 0, and 1, I would end up getting 1/2, 1, 2. My logarithmic, then t-chart, is going to be 1/2, -1, 1, 0, and 2, 1. So at the moment, let's go ahead and graph those first. So 1/2, -1 is going to be there, 1, 0 is going to be there, and 2, 1 is going to be here. Now this is what I was talking about with numbers being on the outside. There's nothing on the inside, so no horizontal shift. I do have a number on the outside though, and we learned that any numbers on the outside are going to shift vertical, which would be down 3 in this instance. So we're going to take all of our coordinates and move them down 3. So 1, 2, 3, put our new coordinate, 1, 2, 3 there, and then 1, 2, 3 would be here. Now, our asymptote is completely dependent on our x values, our shift that is left and right. So since my graph did not shift left or right, x equals 0 is going to remain our asymptote. So my graph is going to look like this still. And the good thing about that is my range is going to stay the same, but also my domain is still going to be the same because it didn't shift to the left or right. And all we care about for the domain is our x values, which go from there to the right to infinity. All right. All I care about, 1/3. I want 1/3 to the x value. Okay, so I'm going to plug in my normal numbers of -1, 0, 1. I'm going to get 3, 1, 1/3. Okay, if I do my logarithmic t-chart, I'm going to get 3, -1, 1, 0, 1/3, 1. So I'm going to go to my graph and plug in, I'm going to graph 3, -1. I'm going to graph 1, 0. And 1/3, 1. Alright, we've left the asymptote alone at the moment because this time I know my -2 is on the outside, so it's going to shift down just like we did in the last problem. However, remember that horizontal shifts are opposite, so I'm not moving it right 4, I'm going to move it left 4, meaning my asymptote that was normally on 0, 0 is now going to be shifted this direction 4. So I'm moving all my coordinates left 4 and down 2, meaning my asymptote is also going to shift to x is equal to -4. Okay, that -4 comes from this. Okay, so I'm going to go ahead and move all my coordinates 4 and down 2. So 1, 2, 3, 4, 1, 2 would be here, this coordinate would be here, and this coordinate would be right here. And then I can go ahead and graph my line. My range is going to stay the same of -infinity to +infinity. However, my range or my domain is now shifted, meaning my x equals -4 is now going to be -4 as my starting point, and it's going to go to +infinity to the right. All right, that's the last example we're going to do. Good luck.